Hello everyone, welcome to BIM Modeler channel. This is Rajkumar. So we are discussing continuous parametric family creations on advanced topics, and as a BIM Modeler channels, we are creating a continuous support to those families to learn how to create advanced topics such as duct fitting, pipe fittings, and also we are planning to create other fixtures and supports all elements one by one after these videos. We also doing continuous sessions on architectural basic tutorials on the other time frame, and if you are interested you can participate. We do have scheduled other topics like such as Dynamo and BIM topics, related topics, and we have scheduled after this tutorials are over with the completions. Okay, so if you have any questions on the same, you can leave a comment on the below. And meanwhile, if you're not subscribed to the channels for recent updates, you can subscribe and click the bell so that you will be able to get the notification whenever I start the tutorials online. So that will be great help. So you can see that there are more tutorials are coming up, as you can see. And if you have anything to be fulfilled or anything to be shown to learn, need to be learned, you can just give a comment on the video that you are watching, and it will be created on the upcoming request based on the users from you. So let's dive into duct fitting, and which is transitions. You can see that in shaded mode, and this is very simple transition that we have. But if you have checked the family, and the parameters are large, so as compared with the elbow family, this family contains more parameters, more formulas than the other fittings that we have. So what are these formulas? Don't hesitate. So what are these formulas? We're going to discuss one by one in this tutorials. And if you see, we're going to discuss one by one how do we do. All the parameters are explained how it can be used in later tutorials, and you will be able to apply the same into your family own, and you can customize it, and as per your requirement the transition can be defined. So let's start one by one. There are many questions based on this, and so we have to answer those one by one. While from the starting, let us go back to the project. So I have a project, and there are few elements, the duct fitting elements which is created, and ducts also created, and you may be aware of this. The duct have different sizes. You can have it in height also in a different size, say 36 and 42, 36 it has. And similarly you can have a 14 and 12, a different size to the duct, which is possible. And while we do like this, and we do create a transitions like a justification for the duct. Once if it is created, you can select all together and go to the justification, or while drawing you can define your justifications. And you can see the arrow in the middle, so the justification which is on the center. To understand the concept, so I'm explaining how do we defining these concepts, how do we are defining a justification for a duct. So I'm just explaining it so that you will be able to understand it very clearly how this family works actually. So in plan view, if you see the same thing, and you can control it, while you change it the arrow changes the side. We are just controlling the width side, and it automatically aligned to the one side. So the justification will be aligned on the top side. Similarly, you can do it on the height side also. You can see it in 3D or section view, and you just select all together and say justify, and say on the top finish, so it will be aligned to the top. So similar to the other ducts, you can do the justification on left, right, and you can change that wishes that you needed and to fulfill your design requirement. Okay, so what is the reason that I am saying this? So let us start this family, and we'll discuss one by one. Let me go As I told you, and we are discussing advanced topic, don't hesitate. If you are doing it one by one, if you are following the steps, you will be able to grasp the things and fully, and you will be able to work out whatever the requirements that is need for this family. So you can go ahead and you can do it one by one. And if you're not doing anything well, so you can come back again and retry it one more time, and you can get to know. Or otherwise, leave the comment below. So let us discuss what is happening with the family, so we can share and work. Okay, let's say we wanted to start a fresh family. So as I have mentioned in the earliest tutorials, the selection of template is very much important. So selecting template, file, new family, you can go to the metric templates or you can go to the imperial templates, whatever that you needed. So as I mentioned in the template selection setups, the basic family creations, and if you are not aware of this, I will give the link above, so you can click on the link. And the duct transition family is available. You can take simply this family, or you can take a generic model, which is this one, normal generic model, and you can create your own family from the scratch. So what is the difference? So if you start with a transition family from here, the setups, if you see the preview, the setups are done already. Or if you wanted to start from the fresh, you can start with this generic model option. And start with this generic model, and I'm saving this family name as Duct rectangular duct transition is the default family name. So I would like to define it as rectangular duct transition, which is our name, and by default family name is which is transition angle. And let me save this as one backup. Save. I don't want any other views. Let me close all these things. So we have one example project, and we have one already done family opened, and we have a fresh family and in this place. So let us discuss. As we know that this is the center position of our family, so we have to consider about what is this family in the center positions. So this may take a long time because I wanted to explain it each and every steps very clearly to make it understand everything possible to the person who is learning it. Okay, so when we started, we have to change the category. Before changing the category, if you check, there is no much parameters, and if you are changing the category to a duct fitting, and if you change this part type must, you have to change this, it is a transition. So if you change this option and give OK, by default it creates two parameters, and that's the thing. So while we discussed, you can see in our presentations, so the selection of template is very much important, and the parameter creations, while you create the parameters, these two parameters are available by default, offset width and offset height, which is available by default. These are the main parameters which is required, duct width and duct height. So in a transition, we're going to connect two ducts, so automatically width 1 and width 2 and height 1, height 2 will be there. So it will be calculated based on an angle. It will be in a particular slope, so it requires an angle. So these are the main parameters we require. So based on that, so we need to have a sub parameter to control our constraint of the same. So it is very similar parameters of value of the same, all four. That is the alpha width of height, and the helping parameters are nothing but the parameters which is used for our constraining purpose and calculation purpose. To define our length and the angle parameters are calculated by using the different formulas such as trigonometry formulas are used, and derivatives are different. Derivative form are used for calculating the length of the segment. To define angle of the segment, it is used, and we're going to discuss about the same in the later of the slide. Okay, so let's say what are the parameters that we need. We can create it, and as we go ahead, and I have to mention that all parameters are instance except angle parameter. You have to define it all the parameters are instance and except angle parameter, and all parameters are this parameter is angle, and the parameters which is num 1 2 3 4 8 all are number category, and remaining parameters are HVAC duct size category, so which is supposed not to be defined as length, that it is must be defined as duct size. So that is the main things that you have to remember. All are instance and duct size as a category that you have to define while you create the parameters. Okay, so as I mentioned, these two parameters are coming by default from the template once you have changed the category of the model. Let's save the family and make sure you have the center axis ticked, okay, and you have the transition in place. We have to create n number of reference planes to understand it. So if you wanted to understand it very clearly, I have to go for a paint object, and if you see in paint, I can draw a transition like this in a plan view. So this will be the width and 1, and this will be the width 2. The primary, the bigger one is the width 1 and the smaller one is the width 2. And the reference line, you have to have the reference line one in this place, the other one in this place, totally 2. And for the same this edges, we are doing it for this edges. So for this we have to have another center axis, and we have 3 totally for this side. For the other side, so we have to have another reference plane, say for this edges, because the width 2 will have a different dimensions, so we'll go like this. And for the width, the reason why in the times of we have explained about justifications, to see that width 2, it moves from one side to the other side. You can see it moves top side, or it moves left side or top side, like that. It must have a center axis so that we can move it around along with these two blue lines, their axis. So these 3 blue lines will work together, and these 3 green lines work together. This is for width. Similarly, we have to have the height side. You have to go to the height and you have to define the same setup, and you have to define it. So this is how it works. And you may have noticed it, there is one more reference plane which is in the bottom, like this, which is there. So which is by default, which is referenced with the dimension of 10 feet, it is controlled. It is locked with 10 feet from the center axis. I mean, from this edge axis to this position, it is locked 10 feet. You can define your own length, and people are taking it as 10 feet as a constant length. You can take it and you can define your own length. On the other side, if you see from the blue line, they will, you say from the blue line, they will take the control here, and they will assign as the duct. So duct width, there are 2 parameters which is created. So width offset parameter will be assigned to this constraint. So why it is the width offset, why we are assigning like this parameter? So we should have a control always from axis, this axis, how much distance it's supposed to move. So we are defining it at separate distance, and we are calculating it how much distance it's supposed to be moved from this axis. So we are calculating like this. For that reason only, the width offset value will be created automatically. If you see in the place, these two are interrelated. Width offset and offset width are interrelated, so we can define those formulas later on. So the only thing is to define the reference plane in the bottom. It is to constrain the 2 different profiles. The 2 different profiles mean the green one and the blue one need to be controlled apart from one from the other. So we are creating this reference plane 10 feet apart in the width side and height side, both the sides. Okay, let us create. So consider this is for the main, because width 1 center axis, we can consider this as a center axis, and for width 2 center axis we have to draw it. and create similar CS for the bigger size width 1 and for the smaller size width 2, and similarly we have to have a smaller size and smaller size edges. 2 edges are created, and for the smaller size center axis will be created in this place, and there are 2 reference planes on the same place. And the beauty of this one is to identify the differentiation while doing dimensions. We have to name this as width to center line or plane, so that while we do a dimensions, we can understand their name in the status bar in the bottom here. While you highlight, it will show the name automatically. So you can rename this also if it is required, because by default it is front and center views automatically. We need one more reference plane in the bottom, and these reference plane will be created like this. And do remember, you have to define these as strong or weak or not a reference. So based on this, we have a control. The grids will be shown, so you can define it as a not a reference. That will be good option. So we are defining what is the difference between this not a reference, strong reference separately as separate video, so that you will be able to understand it very clearly. Okay, so this is how you are defining it for width. Similarly, you have to define it for height side also. So let's make this dimensions first. So from here to here. So this is how the by default template will be defined. And if you need to, if you wanted to have a imperial unit, you can change the imperial unit from here, 310 fractional inches, and same in unit HVAC duct size we have to change to 310 decimal inches or fractional inches. Okay, it is, I'm specifying this as a 10 feet. You can keep your own length and lock this. Whenever it moves, it will move with the 10 feet, and we don't have to worry about anything about that. So but do remember, so we have to constrain this, the outer edge with the center, this outer edge like this, and equal constrain it. And similarly, you have to constrain this with this reference plane width to constrain with this one, and equal constraint. And similarly, and you can align it if it is needed for initial time like this, and you can make a dimensions over to the other side and to this inside. Similarly, the outside and to the center. Do remember, I'm not selecting the other one, the center one, like this. So we have to do the same settings to our other side for our height. So you can define it in the front view for the height purpose, or all together you can define it. You may have defined in this place, so which is, I don't want it. I wanted to define it in the front view. Let us say create similar, and this will be we can hide this reference level if it is disturbing you. Create similar, outer edge top, outer edge bottom, and inner edge and inner edge top. We have to have another one more reference plane for us to define center axis width to center plane. And if I make HH and level HH, so you can see that there are 3 elements in this place while we do it. So always do remember to check your list whether the elements are properly constrained. let's make outer to outer and the other reference plane and equal constraint, and which cannot be moved, and it's not a problem. And again, this is inside, this is off width. Similarly to this side, equal constraint to this side dimension to the off dimension. We can make it align with this element. Okay, let's make these dimensions as equal. It will be good actually. So for that reasons, I'm selecting this and saying 2.5, the other side 2.5. Now it is possible to make it as equal. Okay, so whenever I change the outer portions, the other portion also it get changed equally. Now, so it is time actually, so we have to change our parameters, we have to assign the parameters. Let's go back to the floor plan and create one more reference line in this place. So as you know, this is the center axis origin, so the center origin must be in this position and the primary connector will be in this positions, and the transition go like this. So we have to draw it in the right side, or you can draw it in the left side also, it is possible, and it is for us to define it. Okay, so once everything, these settings are done, so we have to, it's time, we have to create the parameters and assign it. So what are the parameters? So as we discussed earlier, so these are the parameters that we have to create. As I defined, it is the most of the settings are duct HVAC, duct size. The others are number 1 to number 8s are called numbers. So we have to define it and we have to define their formulas, and let's start from that. Okay, so these are the two parameters which is available by default. I need duct width, as I mentioned earlier, so it's supposed to be HVAC, duct size, and all the parameters supposed to be a instance parameter except angle parameter, and say okay, and everything looks good. Okay, and going to the next one, duct width 2 and HVAC duct size. Why we are defining it as a duct size? So that the system understands it automatically. When you are connecting it from the duct, it will take the duct size and the transition will be updated automatically, and these two heights will be calculated automatically by the systems, and the value will be populated. For us now, we can apply some values to this as 12 inch and 12 inch, and but in case if you needed to define as a different value, you can define. The width one is the bigger size, so you can define it as 24, and this other one is 12 inch as smaller one. Similarly, we need to have height, so duct heights 1, HVAC, duct size, instance. Okay, and make sure everything is default. Default means it is an instance parameter, and going to create second parameter, HVAC, duct size, instance. Okay, so the first one is the bigger one, 24, and the other one is 12, smaller size. Okay, so we need to have angle dimensions. Angle, it is supposed to be a angle, and it is not required to be in dimensions, it can be in constraint, and it is not instance, it's supposed to be a type, and say okay. Okay, so let it keep it as 45 degree and create one more parameters, the sub parameters that we have discussed, and how width it is. So it can be used, the formulas will be very simple. From the width, it will be duct width, it will be defined divided by 2, and it supports HVAC duct size instance. And HVAC duct size and duct height of height and is HVAC duct size instance. Okay, so everything looks good, and we have to assign the formulas as for the duct width 1. We have to assign the formulas, and width 1, this formula. For the width 2, we have to divide it by 2 and say height. For height it will be 1 and 2. So the values we are calculating, these are the sub parameters which is derived from these parameters. So we need all other remaining helping parameters, and as of now I will create a new type as 45 degree and say OK, so that I can save the family and apply the values to this one. So it is locked, and we have to do one more dimension with the other reference line. You can define it as, so when you're applying that, you have a width offset parameter. Make sure that you have a width offset. We have an offset width, so we have to create the width offset, the helping parameters, and we can assign it. Go to the elevation view, so make sure that we have front view, but we don't have an additional reference line which is defined from our anything level or reference center reference line, which is 10 feet apart, and it must be locked. It should not be the other dimension. It must be from this reference line width through center plane, and it must be assigned with the height, offset height. Okay, so these are the things. Let's go back to the parameter, sorry, save and go back to the parameter, and we have to create the helping parameters such as width, offset. It is HVAC duct size instance. Okay, and the formula will be the 10 feet minus duct width by 2. It means half width 1 plus offset width. Offset width, which is nothing but from here, from the defined value offset width, it's taking the value and it's making it. So we are trying to calculate the value which is the plus value of the offset width plus, and the width value you are minusing it, and we are getting the this gap from the center, the end of this element to the bottom of the element. So we are trying to calculate that value, and similarly we have to calculate it for height, so which is called height offset, and it is HVAC duct size dimension instance property. Okay, 10 feet like this. Let's go back and assign our all the parameters. This is, we are in front view, so it is height actually, HEIG height, and it is height offset, and the parameter will be assigned, and these are the heights, which is height 1 and height 2. This one is height 1, duct height 1. On the other side we have duct height 2. Yes, it moves inside, and This is the duct height 1 off. So let me type half is 1. So it's over constraining, so you can remove this equal constraint and let's assign this value as half 1. So if it changes, the other element size also changes. And making sure the same things, and assign this as height 2 and half height 2, half height 2, is locked, constraint and locked. You can see that, and make sure every time you do it's properly constrained or not. Do check that. This is the parameter that we have to assign because it's from the second reference line. So we have to assign this as width, and which is called width offset, and this one it is not locked, and the other one which is locked. And this side width, it is full width, it is 1 width 1. The other side is width 2. And we don't need this equal reference anymore. This side not anymore. Width to off width, so off width to this side of width 1. That's it. So we have assigned the constraints and it is done. So we need to have one more parameter, duct length, so which is also a main parameter which requires actually is all the time, so which is defined at the end of the time supposed to be. So let's create a dimension for this and save this family one more time and go back to the parameters. Let us create this helping parameters, which is are these parameters. So we have defined width offset and height offset, and width delta we have to find out. So what is the width delta? So we have defined it, we have calculated the transition from the transition bottom edge to the bottom reference plane height, and using that also we have a difference between duct width 1 and duct width 2. So which side it's supposed to be. So while we model in Revit, we may have a chance that, and if you go back and if you have a chance that it may be the other side may be the bigger size and the other side, the opposite side, vice versa, it can be a smaller size. So anything can happen in any sides. So or the width will be higher and bigger. So to compare this, so we have to apply this formula. So which side is bigger? So we have to define it first. We have to calculate which side is first. So we are going to use an abs function and if function and tan functions. These are the three major functions that we are going to use. So make sure that in Autodesk, what are these functions do? The abs functions does, we have discussed already about tan function and if functions for the trigonometry and selecting the if conditions, if else conditions. But abs parameter, the abs parameters always converts your negative elements to a positive elements always. Whenever you apply a negative elements to the abs functions, the result will be the positive value of the same. If you apply the positive, it will be the positive again. So that's how the absolute value it gives actually. So let's start creating a width delta. Delta, which is nothing but the name itself, you can understand the difference between the difference value. Delta is the difference value. So we are trying to understand which is bigger, width 1 is bigger or width 2 is bigger. So if width 1 is bigger, that's a condition. If width 1 is bigger, the value of resultant value will be width 1 minus width 2. If it is not, automatically the width 2 will be bigger. In that case, width 2 minus width 1. So this is the delta width delta formula. Similarly, we have a height delta formula to find out what is the difference between width and height. So width, height 1 and height 2, which one is bigger and which one is smaller. We have to find out which side we have to turn the transitions. From the delta value, we will be able to find out maximum delta value later on to define our length of the duct. Okay, so let us come back and define first parameter as your width delta. And this, as I mentioned, it is a HVAC duct size in all the places, and it is instance parameter, and say okay. And the formula will be very simple if else formula, which it compares the both the widths with 1 and with 2 and results the value of the bigger minus smaller. Similarly, we have height delta and HVAC duct size instance, okay, and it calculates and it finds out which parameter is bigger and higher, and it resulted the value of after calculating this one, similar one. Okay, so let's say, so we have to have parameter max delta to calculate based on our width delta and height delta. It will result the parameter as length 1 and length 2. Let's we create the parameters such as helping parameters. Okay, so it will be delta 1. So these all are the parameters are helping parameters. You can keep this as a HVAC duct, and it is going to be instance, and making sure that the spelling is right, and it is a helping parameter, so you can modify that into a other category, and okay. Similarly, you can create the delta 2 parameter, and which is also a HVAC duct size parameter instance. Is not for dimensions other. It will be grouped under other, so that we can see it clearly which parameters are controlling majorly and which parameters are controlling parametrically. Okay, so the other parameters are num1 to num8, so we have to create it as a number. So let me say the num1 will be the number of instance num1, and it will be the common number, and it goes automatically to the other category instance. Okay, next one, num2, its number. So let me explain you later, once I have completed these filling the functions, how these parameters are working, and so how these all are need to be defined. Actually, these parameters are simple, and so we can define it by ourselves by using formulas. Okay, so this will be under number, another category instance. Okay, num4 number instance, num5 per instance, and the parameters number 6 number instance, 7 number instance, other instance. So we can use this parameter filling options automatically by using Dynamo. We can fill automatically these parameters by Dynamos, and we have to discuss about it as separate tutorial for a week at least. There are different ways that you can do. So we are planning to do that at first, actually, maximum cases. So this is number 8 as the instance parameters. These are the 8 parameters that we require, because we have 4 into 4 corners. The options are very simple. So when you do a transition in a different alignments, left align, right align, or top bottom. So there are 8 different ways that these 8 different controls, number controls, defines that how much distance it's supposed to move, and the other parameters based on those, and it will calculate the length parameters for our duct length. So there are 2 ways, height length we have to calculate and width length we have to calculate. So we are defining it as length 1 and length 2. So this will be the, it is not normal common length, it is HVAC duct size and instance, and it is going to be in other. Similarly, we have length 2, and it's HVAC duct size other instance. Okay, so we have to apply the formulas. Say for a delta, so the delta of 1, which results the offset width, which is calculated from here, offset width, this value, and minus of width 1, and the result value, if it is minus, so it will make it as round off value and it will give you the result in this place. Similarly, for delta 2, it will calculate the height value and the difference value will be resulted in here. The length 1, as I mentioned, so it is calculated from the numbers. So the length 1 will be the number 3. Actually, this is the formulas which is defined from which is nothing but the square root of x squared, y squared, and z squared, and in the whole square root plus num 8, which is nothing but o squared, which is defined, and the last digit which defines the converts the unit number unit to inch unit. So these all are the numbers are in the numbers, so if you need to convert to an inch, so it defines and it converts it. Similarly, we have it for height. So we have it for height 1 inch, and for the number 1 to number 8 we have a formulas which is where it calculates the using the trigonometry formulas, it calculates the length value and it defines that as the number in here. So these are the copied parameter values, and if you go one formulas, you can take one formulas and go only one side of the triangle, you can calculate the trigonometry and you can define it, and as you go. I hope everyone is clear about trigonometry formulas, and if somebody who's not coping up or coming up line with trigonometry formulas which is been not tilted, or if you are facing issue with the if else conditions, you can leave a comment so that we can try to answer it if it is possible, and otherwise we will try to match it with the other videos if it is possible. Okay, so do subscribe and let me, yeah, everything is fine, looks fine for me, and we'll say OK button and everything which is created, and let me go back and see. Yes, everything is looks like clean, and as I mentioned earlier, these 4 parameters will be taken from Revit automatically while you connect with the duct, and from these values, that's the reason we are assigning it as duct HVAC duct size. Once if it is these values are taken, and from that these values are calculated by Revit itself, these 2 values, and we have free filled with 12 inches, and the remaining values are interrelated, so automatically these remaining values are calculated from the formulas. So this is how it works. Actually, the total family it works. So once if you have defined your constraints, you can come back here and define your length in the reference level, which is already defined, and I hope the duct length which is not defined yet, so it is new parameter, and which is computer length, and which is HVAC duct size dimension instance. So the computer length will be calculation from the max maximum duct size, the length delta value, which is not defined yet. Actually, we have to define the maximum length value, delta value. So from the bottom helping parameters, it takes the delta value, width or height, which side is bigger, and it gives the resulted value in the maximum delta by using if else conditions. And HVAC duct size. Okay, so what is that formula defines? So the formula which uses the comparison statement between the comparison between the length and width. Let me go back to the notepad and see how it works. And it compares the first if conditions like this, and if it works, both the delta values are 0, which means the width 1 and width 2, if it is equal value 6 inch 6 inch, automatically this value becomes 0. And so similarly, if it is height equal to 0, so automatically the resultant duct length will be 1 inch. So how I'm saying it, so you can go back to Revit and say okay, and say okay, you can go back to project. So once if you are create similar, and if you are creating this duct fitting to this place, we don't have any other duct on the other side, so automatically defines that as equal dimensions in both sides. So if you see this reference plane in plan view, this length will be 1 inch by default. The duct length will be 1 inch by default. So how it works, the formula which defines it, automatically it will become 1 inch. Else, if the value, if it is not equal to 0, so what happens? So it defines as if only width delta equal to 0, then it will be length 1. Or if width 1 it is not equal to 0 and height delta equal to 0, then the resulted value will be length 2. And again else, so these are the if else combined statement. So else, if the condition, it is very simple, if it is 0, if it is not 0, if it is a numerical value, it compares the length 1 and length 2. If it is length 1 is bigger, it will take the length 1, and if length 2 is bigger, it will take the length 2 value, and it defines that as the duct size to our family in this place. So coming back to the family that we are creating, and so still we are constraining it actually for our family. So go to the plan view, take the parameter, the parameters are assigned. So the computer length will be max length, and so this will be the duct length. So you can directly assign the computer length, but we have to have a duct length parameter as usual, because in other fittings also we have to have it. And duct size instance, and it is computer length. So this is how it works actually. The total formula we have applied, and constraints, reference planes we have applied. The only thing that we have to assign is duct length in this place. So once it is done, so you can go to the front view and see it is the same. Duct length both are same, so it is controlled together. So now everything is clear except creating a solid model. So as per our progress, so we have to define selection our template, parameter creation, constraining. So these all are done, so we can go with solid modeling. The solid modeling can be created very much easier. Blend solid modeling we can use, and we can create the models, and we can create the connector and symbol as easy it is to define. So this work plane, which is the center axis, from here to here we have to create. As I mentioned, this left side must be the higher value, width and height must be higher value, the right side must be the smaller value. So that's how I have created the formulas. And so to create a blend, so you can go to the and create tab and take the blend, and we have to draw it in this work plane. You can set the work plane, pick a plane, okay, pick it, and it will ask us to go to the left or right side. So you can go to the any view side, and we are sure that it is the outer side that we are trying to create. So create a outer side and make sure that it overlaps with each elements of the outer side like this, and make sure you're locking with the reference plane. Otherwise you can draw each and every elements individually, and you can go with edit top and draw the inner edge, lock it. Don't forget to lock it. So let me check in 3D or in after finishing the elements whether it is as expected. So going to the floor plan, and it is. So if you see that it is properly managed to create in this direction, and we have to log this reference plane. Only thing is that we have to log align command, take this reference plane, log this, the other side, log it. That's it, as simple as it is. So it is very much easy. So you can create this plan and you will be able to do, and go to 3D and you will be able to see your solid very clearly, and the object it is created automatically. When I go back to the formulas, and you can change the value of the element, say for example duct height 2, we are changing that into 14-inch and apply, it changes. And whenever you create a parameter, make sure that you are creating the right side, you are applying the right one, and whether you are changing it properly and it reflects or not. You have to flex the family and see whether it works properly. And to the other width side, and let's make this as 12, and it works 24. Okay, and angle, so let's say 25-degree, apply, yes, based on the trigonometry formula. So it calculates the length and it applies the length to max, then calculated from the deltas that we defined from the beginning. Okay, so the 45-degree we can define it again. Okay, so you can see that there is no error, so that we have to create the connector. So the solid model which is done, I hope. If anything error comes, then we can resolve it coming back again. Let's create a connector, that connector, and you can click this side. So as I mentioned earlier, so this is the primary side of the connector, because this is the positions that are origin, our center of the family defined, so it must be the primary connector. If you suppose, if you are by mistake, if you have selected the other edge, and you can use the tab to define it. Tab button is very helpful to select the edges to the faces. So if you are forgot to assign the primary this side, so you can select the connector and say reassign primary, so that it will flip to the other side. Similarly, make sure these arrows are one apart another, and click the one connector, say link connector, and select the other connector to define your link between these two connectors, so the Revit understands that this is the primary connector. The flow, it goes from here to here, like that. It understands it very clearly. These two connectors are directly linked. Okay, so let's make it as solid. So we have to assign the parameter this side, which is height 1, duct height 1, and this side 1, which is duct width 1. To the other side, height 2, and this side width 2. Everything is perfect, and select the connector. Don't forget to, after assigning, creating the connectors, don't forget to change this supply air into a fitting, so that you don't have to have any systems. So it can be used in all the air systems, supply air return and exhaust air systems. You don't have to have any parameters which such as angle, you don't have to assign it, and these two parameters are assigned already, height and width, so you don't have to worry about anything. So everything is done perfectly, and you can save the family and load back to the project. And this is the first time we are loading into project, so we may get a chance to place it over to the duct like this. And as we discussed, so we have to change our work plane to a not a reference, so that it will not show the grip, otherwise it will show the grip. So it by mistake we will edit it actually, so we will the grip will be adjusted. We should not do it, so go back. So this is how we have to test the families always and make sure that it works perfect, and select these all reference plane and make this as is reference, not a reference. Similarly to the front view, it should not affect in the section view. Select these reference plane and make this as not a reference. So we will be discussing about the what is a not a reference and strong reference in different videos, so that will be very helpful. And going to the plan view, this one reference. So load into project again, the project, and over the existing version and its parameter. Now if you select our family name, which is rectangle duct transition, which is being created, and if you wanted to assign that into a auto routing, you can do it by selecting edit type, editing routing preference, and the transition. It's not multi-shape transitions, we have to discuss separately. And this is the default template family we have, and this is the only one type we have defined it. Say okay. So now if you are trying to create the same duct type with the justification as center, and make the size to a bigger, width as bigger, and it will be done. And select it, make the justification as left or right, it will be done. And when you go back to the course view, and it shows the symbol as this. So but our symbol is supposed to be like this, so the transition symbol must be something like this. So we have to define our transition symbol as clear as it is. So we have to go back. The transition symbol, always the triangle symbol looks like this one. So only thing that left with is this symbol. So you can come and create your model line, or you can define your annotation, symbolic line, pick line, and you will be able to have the option to pick and lock it, and pick it, lock it. I hope I have clicked it on the connector. Supposed to be not to be connected. Yeah, it is connected properly. So let's save this one more time, and our family, it is in duct rectangular duct transition. Load into project. Okay, what is the existing version, and change this into course. Now it looks perfect, and these are got collapsed, no issues. Come back. So this is a family which we have done it very clearly. So if you have any comments on the same, so you can leave a comments below. So if you like the video, give a like to the video, and do share with the other people, so that they will be also good at their Revit parametric creation, family creation. And we are creating with multiple we are hearing your voice actually. So let us comment on the below, so that I understand what you're thinking and how do I improve it. So we are improving it day by day. That will be great to me actually. Thank you so much, and happy learning. So see you again. Bye bye.